大家好，你好啊，我係 Stephen 啊，歡迎大家嚟到香港城市大學機械工程系嘅 Information Day。咁今日咧，我哋晏晝咧有3個 sections，咁分別有3個老師啦，3個 program leader 講翻我哋機械工程系嘅3個學科嘅啲細節啦，包括航空航天工程啦，機械工程啦，同埋核子風險工程。咁第一個講嘅老師咧或者教授咧係Professor 楊勇OK Professor 楊勇 if you're ready can you share the slide?
Sure, Stephen. Okay, thank you, Stephen, for your introduction. Okay, so yeah, I will first talk about the aerospace in CityU. First of all, thank you coming to this info day. Can everybody see this?
Yes, we can see that.
Okay, so as I said, first thank you for coming to the info day today in CityU. First of all, I would like to, I'm Professor Yong Yan. I'm now as program leader of Aerospace Engineering program in CityU. So I'll be happy to talk about this program in the next 15 minutes. So Aerospace at CityU. So now I think this is the most tenants as high school students, right? So they would like to choose their majors. Okay, so choose universities after the examination, after they finish the college entrance examinations. So Aerospace. So what is this? So before we get started about aerospace, let's look at it. So what so what is Hong Kong is good at? We know Hong Kong is an international aviation hub. Hong Kong is well known as it's a center for the international transportation, for for passengers as well as for goods. So now there are several companies in Hong Kong. They are highly related to the aviation and transportation. For example, like a HACO. HACO is an acronym for Hong Kong Aircraft Engineering Company Limited, HACO, like a China Aircraft Service Limited, and also Hong Kong Airport Service Limited. All these companies related with services and maintenance. So at this point, you may be wondering, okay, so what's the role of aerospace engineering in Hong Kong, right? Is there any relation of Hong Kong with aerospace? So when we talk about aerospace engineering or aerospace technology, we can think of something like a space station, right? So something people can build outside, in the outside the earth, up in the air. And current moment there are 2 space stations up in the air, like the International Space Station, many built by United States and Russia. And also the second one is a Chinese space station built by the China alone. Now, to support the life and the working in aerospace, in the space station, people need to provide the technology that can be, can make life easier. So, if we look at it in the history, there are 3 countries who have been really invested a lot in developing these life supporting systems. Like cosmonaut, that's the Russia. That's the actually this cosmonaut astronaut is a word used by English speaking countries, many US and the UK. And a cosmonaut, that's the word coined by the Russian or by the the Soviet Unions. Okay, so now today people talk about a taikonaut. That's the word coined by the Chinese. Okay, so in general, you can see that the 3 major countries in the world who have invested significantly in the development of aerospace technologies. Their goal is not just to build the space stations, but also they try to explore the outside world. Now, there are currently several lunar exploration projects in China, in US, in European Union, also in Russia. They also claim that, or they also announced that they're gonna have a new lunar exploration project. It's not only for curiosity. It's also because of opportunities outside, in the outer space. We know that on the surface of the moon, there are there's elements called the helium-3, right? The helium could be a very important source of power, and we can for nuclear power. Now, but that kind of elements are quite scarce on the Earth, but in Moon, there are abundance of the helium-3. Aside from Moon, and the people also send their this is also try to explore to study the Mars. So they sent the this is space hovers. Okay, so they land on the surface of the Mars. So this is the current something we know from the news, from the from also from televisions. Okay, so every day we know that. Okay, so different countries, they try to send the rockets. There's this is satellites to outer space. So me wondering what's it for, right? It's only for curiosity, or it's only for is because only show off the power or technology? No, it's not the case, because to develop this aerospace capabilities, we need new materials. So when I talk about aerospace technologies, okay, so it demands the new materials and new structures. And aerospace technology also needs robust and powerful systems. You think about it, if you're an astronaut, right, or you are a taikonaut or a cosmonaut, now sitting in the space station, right, you need to communicate with the people on the Earth. You need to send a device, right? You need to use a device to to study the outer space, to make sure that the space station can function properly. That's why you need powerful and robust systems. Okay, even much more powerful and robust than the systems working on the surface of planet on the Earth. So we need new materials and new systems. And in the meantime, aerospace technology, they're powered by clean energy. Now, just think about it, we cannot burn the fossil fuels out of space, right? Get the power, cannot do that. So we must make use of the clean energies. The first kind of clean energy could come from sun itself. That would be solar energies, right? The second one would be the nuclear energies. Okay, so with the nuclear energy, you can easily provide power to this outer space spacecraft for a long time without worrying about running out of the energy sources. So clean energy is another thing that's highly related to aerospace technology. So aerospace technology also needs the telecommunication technologies or techniques. So Starlink project, we know this is a well-known project, right, in the world. This could be the next generation communication technologies. With the Starlink project, okay, the astronaut or the taikonaut or cosmonaut not only talk to the people on the Earth, but also they can do this online shopping, they can do the online conference. And now the people on the outer space can do this, but also the people on the Earth, on the surface of Earth, can also do this. Okay, when we do online conference regularly in the States, right, because of pandemic. And we will also do online shopping regularly. In the meantime, in the future, we can also do so-called global health. And it means that once you get to the hospital, now maybe the doctors who are now seeing a patient, may sitting at the end of this planet, right? So maybe you can see a doctor in US, in China, in Japan, in other European countries. Even now, personally, physically, still in Hong Kong. But that's needed data. That's needed transmission of data and receiving data without any disruption in the transmission of data flow, right? In this case, we need the aerospace technologies. We need the satellites to help us to transmit and the receival of the data without any time delay. Okay, so that's the other use of aerospace technology. With these aerospace technologies, now it's possible for us to build a smart city. And within the city, within the city, then the data can flow smoothly, okay, regardless of the size of data, right? Currently, we're entering the age of 5G, right? But now very likely, very soon, we can imagine that, we can conceive that we'll be entering the age of 6G, 7G, right? Now, in that case, we'll connect ourselves, the individuals, to the machines, right? Like, this, not just the cell phones, but also the text, the cars, the airplanes, right? The hospitals, okay? So all the human activities will be somehow based on the data, right? So, and the infrastructure that support the flow of the data will be based on the aerospace. They're based on our satellites, which is somehow it's something hovering around the area, okay, just hovering above the city. So smart city is ultimate goal for aerospace technology. It's one of the possible applications on the goal. Right? So that's the possible application of aerospace technologies. So in terms of the economy, in terms of the money, right? So expect that according to the the Morgan Stanley research, okay, in 2040, that will be about 18 years from now, the whole scale of aerospace that can be directly related to the aerospace economy will be over $1 billion. Okay, so that's the big market, okay, for us. So back to Hong Kong. So we know that aerospace technology is very useful, right? They can reshaping our world. But Hong Kong ready to develop aerospace? Or in other words, can we find a good job which is related to aerospace engineering? The answer is yes. Now in 2021, actually in Hong Kong, there's a company called Hong Kong Aerospace Technology Group. Okay, they just launched in. Okay, so now, and this is Hong Kong Aerospace. We do have, so Hong Kong Aerospace is studying. Okay, so because time limit, okay, I will go directly to the program, and I think after this session, there's another session dedicated to aerospace engineering only alone. Okay, so we'll get back to the details of aerospace. But anyway, so let's move to. I will talk about this is a background, but due to time limit, okay, so I would like to talk just using 1 or 2 minutes to talk about the program. But I would like to talk more about aerospace. And okay, so this is now for us. Simply speaking, okay, aerospace in Hong Kong is actually quite promising. I think it's now because that provides the foundations, one of the possible foundations for the reindustrialization of Hong Kong, right? To provide good high-paid jobs. In CityU, we designed a curriculum structure called two-stream curriculum structure for aerospace. In general, we focus on two things. In the first and second year, students are going to take the 35 per units worth courses. That's related to these foundations of aerospace. We'll study the aerospace materials, aerospace manufacturing, aerospace system design, and so on and so forth. After the second year, now students can choose one of the concentrations to focus on. One concentration or one stream is aerospace material stream. The other one is aerospace system stream. Okay, so after finish all the coursework, okay, students should be ready to take a job related to aerospace manufacturing. Okay, so this is aerospace engineering. It's going to be accredited by the Hong Kong IE, Hong Kong Institute of Engineers, and this whole aerospace engineering is going to cover 7 areas, like fluid mechanics, propulsion, structural solid mechanics, material science, design manufacturing, electrical and electronic systems, as well as communication systems. Aerospace can get strong support from CityU, and mechanical engineering department going to be a host of the program. But aside from mechanical engineering, we have material science engineering, electrical and electronic engineering, the system engineer, and the School of Energy and the Environment, and School of Data Science. Okay, those academic units can help us, okay, to build a strong aerospace engineering program. As I said, aerospace engineering is an interdisciplinary field. Okay, so now when students get into this program, they will study different coursework. So they study different topics. Okay. As I said, due to time limit, I have to stop here. Okay, so I think Stephen tell me that I have to stop here. Okay, so other people have enough time to talk about their own programs. But I said, okay, I think in next section we're going to talk about aerospace alone. Okay, so we can get into the more details about what happens to Hong Kong with respect to the development of aerospace engineering. Okay, thank you.
Thanks a lot. 下一個 speaker 咧係 Professor 張，佢會講下機械工程系嘅細節啦。Professor 張 you can start if you're ready.
Wait.
Let's start now if you
yeah,
can.
you can see my screen.
Yes, we can.
Yeah. Okay. So hello everyone. So welcome to a Bachelor of Engineering in MNE, Mechanical Engineering at CityU. So our MNE program offers comprehensive and dynamic curriculum which prepare our students with competent capability to support technology advances and the sustainable development of the industries. In our MNE program, we have four focuses. One is called product design and automation, and the second is the materials engineering and the mechanics. Third is the thermofluid systems, and the fourth one is the micro and nano engineering. So I will discuss them one by one very briefly. For product design, as we know, product design is very important. Like for example, the engine for Boeing 787 and the engine for the the very advanced cars, they are the key part for the airplanes and the cars. The problem, for example, for the engine, it needs to be operated at a high temperature and high speed for a very long time. That's why the reliability is very important for the reliable airplane. That's why how to design a very reliable engine is very important. During the design of this product, mechanical engineering plays a very important role, both for the engine and for the cars, and for the airplane, and for many kinds of engines. That's why product design is one focus of our program. Second one is the engineering materials. As we know, materials are very important for different products. For example, as we know, the Swiss watch is very famous in the world. For example, about 20 years ago, I bought a watch in Switzerland. Now it's still running very well. So of course, there are many reasons. One of the key reasons is the materials made of the watch. So that the materials for these products should be very reliable, should be able to use for a long time. So that's why how to select, how to choose proper materials for different products is very important. So in our program, so we will have several core courses and elective courses to teach our students how to relate to the engineering materials, different materials for different applications. For example, for this one, for the polymer and the contact lines, that's a so-called biocompatible materials. This material should be soft enough at the same time should be compatible to our human eye. And the third one is the robot and automation. Now you see in the modern factory, we are seeing more and more robots. There are fewer workers, few human beings working in the factory, more and more robots. Because for the robot, they can work for 24 hours. We don't need to pay for them. We need to feed food for them. It's very, so but in the long term, the cost for supporting a robot is very low. However, their working efficiency is very high. In fact, for example, our ME students, during the past years, they joined many contests, like a RoboCoin. This one is very famous in Hong Kong. So they win a lot of awards in robot and automation. Again, so one of the focus of our program is robot and automation. We have several courses covering robot and automation. The last one is called micro and nano technology. So this one, micro and nano technology, is we can see is one of the future technologies for engineering. They are very small. However, they are very reliable. Let's take the phone for one example. You see, all of us are using cell phone. Do you know many components of the phones? In fact, they are made by micro technology. For example, the pressure sensor, touch sensor. So for example, when we are touching the text using our cell phone, in fact, we are using the so-called pressure sensor and the touch sensor. Here, the pressure sensor, touch sensor, they are made by micro technology. But another one, for example, some cell phone can tell you the humidity, including the microphone, this one. So we are talking using the cell phone. In fact, we are using the MEMS technology. In fact, this is just one example. In the future, we believe that micro and nano technology will play a very important role in engineering. You will see more and more products made by micro and nano technology. So that's one of the future technologies for engineering and also for our society. For mechanical engineering, for our graduates, in fact, there are many career opportunities. For example, our graduates are able to work in different sectors and industries, such as transportation, like MTR, security and automation systems, for example, in the airport, manufacturing, building and construction, hospital and power company. For this one, building and construction, you see, in fact, as I mentioned, one of our focus is thermal fluid systems. So our students will learn many courses, several courses related to so-called heating, ventilation, and air conditioning systems. So all of them related to thermal and heat system. That's why our graduates have the knowledge to work in the building and construction sector. Later, I will give you more examples. In fact, these are list. They can work at different, like in automobile, in R&D researcher, in medical product designer for many things. HVAC in construction, even in, for some years, some of them can work as a CTO or have their own company. Thanks.
The next speaker will be our Precious Zhao. Are you ready to share the slides with the?
Yes, Stephen, yes, yeah.
Thank you. Thanks a lot.
Okay. We share. Okay. Yeah, good afternoon, everybody. My name is Jiyun Zhao, a professor from Nuclear and Risk Engineering program. My talk, the topic is our life in the nuclear age. Why Nuclear and Risk Engineering program is needed? 23% electricity in Hong Kong from nuclear. Here we can see the distribution, the Hong Kong fuel mix. The coal about 53%, nuclear 23%, the gas 22%. Significant increase of the use of nuclear energy in China, especially around the Pearl River Delta region. 35 nuclear power reactors in operation, producing total of 33.6 gigawatt electricity, already increased to more than 58 gigawatt electricity by 2020, and probably more than 200 gigawatt electricity by 2030, and 400 gigawatt electricity by 2050. Here is the BEng nuclear power plant. It's very close to Hong Kong, and Hong Kong is importing electricity from this power plant. So environmental problem in China. Here you can see in Beijing, forbidden city, especially during winter time, it's very heavily polluted. This is the comparison between the clear day and the polluted day for Tiananmen Square. Here in Shanghai and Zhengzhou, in the middle of China. Nuclear power plants in mainland China. You can see it's all these power plants kind of on the coast, especially in surrounding Hong Kong. You can see it has a lot of nuclear power plants. China nuclear industry going global. China has exported 2 small PWRs to Pakistan with 2 more under construction. Expertise in nuclear power plant operation and construction had led to project opportunities. Construction of CANDU reactors in Romania and Argentina, and participation in the EPR project in the UK with follow-up projects, development of indigenous generation 3 technology has led to export potentials, exploration of AP1000 and CAP 1400 for Turkey and Africa, These are generation 3 nuclear power plants. Currently, in the world, majority nuclear power plants are generation 2. So this is advanced technology. Hualong number 1 is also generation 3 technology. It's designed by China to be built as a demonstration unit. It's already in operating in China, the first unit in Fujian province. It's likely to export it to other countries like UK, Kenya, and Egypt. Here is collaboration and export of EPR technology to China, to UK, and this is a signing ceremony. Hualong number 1, it's a China-owned designed generation 3 reactor. The power is standard power, about 1,000 megawatt electricity, and it's already been operating now, and the following will be built and exported. And also, besides the nuclear power plants, for nuclear engineering, it has another sector. It's so-called nuclear medicine or medical. Due to aging population, the use of the radiation technology for medical treatments and diagnostics has been increased steadily over the years. Medical radiation professionals to meet the current and future manpower demands. And another sector is risk engineering. Risk engineering is essential to the nuclear industry and also to many big corporations and engineering systems such as MRT. Many companies have now recognized the importance of assessing and managing risk to ensure smooth running of their business. The program UNIX is the first and unique program in Hong Kong. It's highly interdisciplinary in nature, fully taught in English by world-renowned scholars and experts, unique opportunities in exchange and training, and training up a new breed of future scientists, engineering, entrepreneurs. It has 5 related focus areas. The major will concentrate on nuclear engineering, material engineering, medical radiation, risk engineering, and crisis management. Curriculum. The curriculum has been categorized into 8 main program building blocks: general science engineering, nuclear engineering, nuclear medicine and medical radiation, material engineering, risk engineering, crisis management, integrative project, language and out-of-discipline studies. Possible careers: mechanical engineering sector, traditional mechanical design, small fluid applications, electrical and mechanical services. Power generation sector, nuclear and non-nuclear power generation industry, international suppliers of nuclear-related equipment. Radiation applications, medical radiation-related fields in hospitals and diagnostic centers, radiation protection and environmental protection in government departments and private consultancy firms, product research and development in nuclear radiation equipment companies. Financial sector, risk assessment in the financial sector, risk engineering sector, risk engineering and disaster management for government, public utilities, companies, and big corporations, materials engineering applications, materials characterization and testing services, materials engineering in large corporations. CLP basically invested diameter nuclear power plants. It has a big sector on nuclear power. CityU has a low carbon energy education center It's in the AC3 on campus of CityU. If you have time, you can visit. Very welcome to visit. Okay, thank you.
多謝Professor Zhao。咁今日咧，我哋已經係好簡單咁都講咗3個學科嘅細節啦，即係關於佢嘅即係學科嘅安排啦，同埋一啲以後學嘅課程啦。咁因為航空航天工程咧係我哋一個新嘅一個機械工程系嘅主打學科啦。咁我哋4點半咧會有一個半個小時、半個鐘嘅一個另一個簡介咧，就針對航空航天工程嘅一個介紹啦。如果各位家長同埋同學仔如果有興趣嘅話，4點半可以再入我哋嘅Zoom咧，可以聽多即係如果你想對於航空航天有多啲了解咧，4點半係有另一個special 嘅talk 係關於呢個學科嘅。咁而家我哋今日已經係簡介完嘅。如果大家係有啲問題咧，歡迎可以喺呢度問我哋各位教授可以向我哋發問嘅。如果你有問題嘅話，咁你可以unmute yourself， 你可以喺個 chat room 入邊同我哋問嘅。冇問題啊，大家，即係關於呢3個學科嘅。因為我哋3個學科嘅學科主任都喺度啊，所以你可以向佢哋發問嘅。Interview arrangement。我哋對於 JUPAS 收生係冇 interview 嘅。我哋對於收生嘅安排咧，係會睇4個必修嘅學科啦，包括英文、中文、數學啦，同埋一個通識啦，仲有2個選修科啦。咁通常咧，我哋都會對於選修科咧，我哋都會睇最好，即係唔係最好一定會有物理呢樣嘢，你要讀物理咯。咁個分數咧，我哋嘅根據舊年嘅收生嘅情況咧，係對於英文係最低嘅要求係3分啦，中文係3分，之後數學係4分，之後通識係3分，其他嘅選修科咧就係介乎於4分同3分之間咯。呢個係舊年最低嘅一個要求。咁今年咧當然會唔一樣啦。咁其實就可以攞出年即係舊年做一個參考啦。我哋只可以咁講。咁大家仲有冇啲問題關於呢3個 program 咧？收生嘅第1年嘅係大概係70個名額左右個 JUPAS。咁因為今年嘅航空航天係我哋一個新出嘅一個學科啦。咁如果你真係即係對呢個學科好有興趣嘅，其實我哋4點半咧係有一個比較詳細嘅 講解嘅。BEng 會做一個半個小時嘅一個詳細嘅介紹啦。咁如果大家係對航空航天，因為呢個學科係全港比較係一個比較特別嘅一個學科嚟嘅，因為係第一個學科包括航空同埋航天嘅。咁今日如果有嚟到城大聽早上嘅一個簡介嘅時候咧，其實航空同航天係兩樣嘢嚟嘅。咁航空係即係話講緊飛機喺大氣層入邊啦，所以佢嘅嗰啲考慮嘅因素同埋航天即係喺個大氣層以外嘅飛行器啦，所以兩個嘅如果想設計或者製造嗰啲飛行器咧，係兩種唔同嘅概念咯。咁今日晏晝4點半咧，BEng會講解多啲關於呢個學科嘅內容嘅，係啊，咁係咯。如果大家仲有問題，可以喺度問啊。有個同學仔問，如果 for 3個 majors 有冇啲 internship 嘅 opportunity 係好多嘅。因為我哋而家即係入嚟讀嘅學生咧，都會有好多機會去接觸唔同嘅 local 或者international 嘅 company 去做啲 intern 嘅。咁所以我哋有提供好多嘅 internship opportunities for 啲例如城大讀書嘅學生啦。咁仲有咧，即係有啲同學會疑問，因為我哋有3個學科啊，咁究竟係點樣？因為我哋第一年都係一個common year 咁嘅形式入嚟，咁係到第2年咧，我只會按照學生嘅意願去揀邊個學科去讀嘅。咁我哋而家都即係會盡我哋能力去俾，即係你如果係想讀機械工程系嘅，或者係想讀核子風險工程系嘅，咁就我哋會盡力按照你嘅意願去，即係會安排你讀邊個學科第2年嘅時候。咁呢個係一個即係話即係in case 你係即係讀到第1年，你覺得你自己好中意核子工程嘅，咁你如果你係即係到時你會揀一個你中意嘅學科，咁我哋都盡量希望可以安排到你讀呢個學科咯。其實呢個 quota 咧就每一年都唔一樣嘅。咁我只係講翻咧，咁我哋當即係當你揀咗你，我哋會俾2個選擇你揀啦。即係因為我哋有3個學科啊嘛，咁我哋會俾2個你中意嘅學科去，即係你揀啦。如果你揀咗嗰2個學科，我哋都正常嚟講，我哋盡量都會安排到啲嗰2個學科俾你讀到嘅，即係隨便是第一個啦，係啦。咁啊 quota 係每一年都唔一樣嘅。因為而家就冇乜問題咧，咁就我哋可能喺度會完咗呢個 section 啦。咁到4點半咧，再提醒大家啦。如果係大家對嗰個航空航天工程係有興趣嘅話，真係可以嚟聽下嘅。好，咁今日就到呢度啦。咁多謝大家啦。OK，好，拜拜。